Look at a map of Central America right now. See that thick band of jungle stretching across Guatemala, southern Mexico, and Belize underneath that canopy. Hidden beneath roots and soil, and 1,000 years of silence, lie the remains of one of the most advanced civilizations that ever existed. At their peak, the Maya numbered more than 19 million people. Their cities rivaled anything in medieval Europe. They had mapped the movements of Venus to within 2 hours of accuracy over 500 years. They'd invented the concept of 0 centuries before Europeans. And then, over the course of about 100 years, they simply walked away from it all. The great cities of the southern lowlands, places like Tikal, Calakmul, Copan, and Palenque, went from bustling centers of commerce and culture to ghost towns swallowed by the jungle. No foreign army conquered them. No single natural disaster wiped them out. The Maya just stopped building, stopped carving their histories into stone, and disappeared into the forest. If you are using this to fall asleep tonight, perfect. This mystery has waited over 1,000 years. It can wait a few more hours while you drift off. Subscribe and stick around. To understand what happened to the Maya, you first need to understand where they lived. The Yucatan Peninsula is essentially a giant slab of limestone that was pushed up from the ocean floor about 10 million years ago. It is flat, it is porous, and it has almost no rivers or lakes on the surface. Water doesn't sit on top of this landscape. It drains straight through the rock into a vast underground aquifer, sometimes hundreds of feet below the surface. The only natural access points are cenotes, sinkholes where the limestone ceiling of underground caverns has collapsed, exposing the water table beneath. Despite what the lush jungle images might suggest, the Yucatan is actually a seasonal desert. The region gets most of its rainfall during a wet season that lasts roughly from May through October. The rest of the year, it barely rains at all, and in the southern lowlands, where the largest Maya cities grew, the water table sits so deep underground that the Maya had no way to reach it with the technology they had. So they became some of the most brilliant water engineers the ancient world ever produced. They designed elaborate systems of reservoirs, canals, and underground cisterns called choltons to capture every drop of rain that fell during the wet season and store it for the months of drought that followed. The choltons were remarkable. Bottle-shaped underground chambers carved into the limestone bedrock and lined with waterproof lime plaster to prevent seepage. Each one connected to a surface collection system designed to funnel rainwater underground, where it would stay cool and protected from evaporation during the brutal dry months. At the city of Tikal alone, researchers have mapped a network of reservoirs capable of holding enough water to sustain tens of thousands of people through an entire dry season. The paved plazas and roads were angled to funnel rainwater into these storage systems. Every surface was designed with water collection in mind. Some of Tikal's reservoirs even used aquatic plants as natural filtration systems. Recent research has shown that the Maya deliberately cultivated water lilies and other aquatic vegetation in their reservoirs to keep the water clean. It was a living water purification system designed more than 1,000 years before modern water treatment plants. It was ingenious, it was sophisticated, and it worked beautifully, as long as the rains came on schedule. but it also meant that the entire civilization was balanced on a knife's edge. Everything depended on predictable rainfall. And rainfall, as we now know, is anything but predictable. In 1995, a team of geologists from the University of Florida published a study that would reshape everything we thought we knew about the Maya collapse. David Hodel, Jason Curtis, and Mark Brenner had been studying sediment cores pulled from the bottom of Lake Chicancanab on the Yucatan Peninsula. These cores are like time capsules buried in mud. Each layer of sediment preserves a chemical record of the conditions that existed when it was deposited. By measuring the oxygen isotopes in tiny shells found within the sediment and the concentration of sulfur in the layers, the team could reconstruct thousands of years of rainfall patterns. What they found was striking. The driest interval of the last 7,000 years fell precisely between 800 and 1000 AD. That window lines up almost exactly with the period archaeologists call the Terminal Classic Collapse, the century or so when the great Maya cities of the southern lowlands were abandoned, one after another. But the evidence didn't stop there. Off the northern coast of Venezuela, in a deep ocean depression called the Cariaco Basin, another team of researchers found a remarkably detailed climate record preserved in ocean sediments. This basin has unique conditions that produce annual layers in the mud on the sea floor, almost like tree rings. The titanium content in those layers tracks how much material was washed from the land into the sea by rainfall. When the rains are heavy, more titanium washes into the basin. When the rains fail, the titanium drops. And what the record showed was not just a single drought, but a recurring pattern of severe dry periods that hammered the Maya world again and again. Think about that for a second. The Maya had survived at least 5 major drought periods before the final collapse. They'd built their cities through dry spells. They'd expanded their populations through them. They'd kept building bigger temples and wider plazas through them. So what made the last 2 droughts so catastrophic that an entire civilization couldn't recover? And this is where it gets really interesting, because the answer isn't simply that the droughts got worse. The answer is that the Maya had fundamentally changed their own environment in ways that made them far more vulnerable than they'd ever been before. And the mechanism of that change was something so basic, so essential to their civilization, that they couldn't have stopped doing it, even if they'd understood the consequences. They were cutting down their forests. Every single city the Maya built required staggering amounts of wood. They needed it for cooking. They needed it for construction. They needed it for the fires that cleared new farmland through slash and burn agriculture. But most of all, they needed it for something you wouldn't expect: lime plaster. That smooth white coating that covered every Maya temple, every palace, every plaza, every road. Making lime plaster requires heating limestone to extremely high temperatures, and the only fuel the Maya had was wood. Archaeologist Thomas Sever, from the University of Alabama, estimated that it took 20 trees to produce enough lime plaster for just 1 square meter of cityscape. 20 trees for 1 square meter. Now picture Tikal at its peak. Picture its towering temples, its enormous plazas, its miles of paved roads, the causeways connecting different parts of the city, every surface covered in that brilliant white plaster. The number of trees required is almost incomprehensible, and Tikal was just one city among dozens. Across the southern lowlands, the Maya were simultaneously building and maintaining some of the most elaborate urban centers in the ancient world. Each one demanded more wood, more cleared land, more plaster, more fuel. The forests were disappearing at an accelerating rate. At the same time, the population was growing. At their peak, Maya cities in the southern lowlands reached population densities of over 2,000 people per square mile, comparable to modern Los Angeles County. Even rural areas supported 200 to 400 people per square mile. All of those people needed to eat, and feeding them meant clearing even more forest for cornfields. The Maya practiced slash and burn agriculture. They'd cut down a section of forest, burn the vegetation, and plant crops in the nutrient-rich ash. It worked well for a few years, but the tropical soil is thin and fragile. Without the forest root systems holding it together, the nutrients washed away quickly, and the farmers had to move on and clear more forest. In the traditional system, farmers would let the cleared land lie fallow for years, sometimes decades, allowing the forest to slowly regenerate and rebuild the soil. This cycle worked when populations were small and land was abundant. There was always another patch of forest to clear while the old fields recovered. As the population grew, the fallow periods got shorter. Farmers couldn't wait long enough for the forest to regenerate and the soil to recover before they needed the land again. The soil became thinner, less productive, more fragile. Researchers studying soil cores from across the Maya lowlands have found thick layers of eroded material that accumulated in lakes and valleys during the Classic period, evidence of massive topsoil loss. These deposits are called Maya clay. They're a distinctive layer of colluvial sediment found at the bottom of lakes throughout the region. The physical remains of hillsides that washed away during centuries of intensive farming. In some lakes, the Maya clay layer is so thick that it tells a story of environmental transformation on a scale that is hard to comprehend. And here is where the fatal feedback loop begins. When you replace dark tropical forest with lighter-colored crops and bare soil, the land reflects more sunlight back into space instead of absorbing it. Less absorbed sunlight means less evaporation from the surface. Less evaporation means fewer clouds forming overhead. Fewer clouds means less rain. It is a vicious cycle. Less rain means worse harvests. Worse harvests mean more pressure to clear more forest for farmland. More cleared forest means even less rain. Each turn of the cycle makes the next turn worse, and the Maya were spinning this wheel faster and faster with each passing decade. A 2012 study led by Benjamin Cook from Columbia University's Lamont Doherty Earth Observatory ran computer simulations to test exactly this effect. They reconstructed the progressive loss of forest cover across Maya territory as the civilization expanded, then modeled what that deforestation would have done to regional rainfall patterns. The results were sobering. In the heavily deforested Yucatan Peninsula, the simulations showed that rainfall would have declined by as much as 15%. Across the broader Maya region, including southern Mexico, it would have dropped by 5 to 15%. Overall, The study attributed 60% of the total drying to deforestation alone. Think about what that means. The Maya weren't just victims of a drought that came from somewhere else. They were actively making the drought worse through their own actions. Every tree they cut down to build a temple or clear a field was reducing the rainfall they depended on for survival. They were engineering their own water crisis. Now, you might be thinking that the Maya should have noticed what was happening and changed course. But consider their position. The lime plaster wasn't optional. It was the foundation of their architecture, their roads, their water collection systems. Even their diet depended on lime. The Maya soaked their corn in lime water through a process called nixtamalization, which released essential nutrients like niacin. Without it, they would have developed pellagra, a devastating vitamin deficiency disease, and the building programs weren't vanity projects. In Maya society, political legitimacy was demonstrated through monumental construction. A king who stopped building was a king who lost power. Each city-state competed with its neighbors to construct bigger temples, wider plazas, more impressive monuments. Cutting the building program meant losing status, losing allies, and potentially losing everything. This political pressure becomes even clearer when you look at the warfare that was escalating throughout the late Classic period. The Maya world wasn't a unified empire. It was a collection of rival city-states, locked in shifting alliances and bitter conflicts that stretched across centuries. The most famous of these conflicts is what archaeologists call the Star Wars, named for the star-related glyphs that mark warfare events in Maya inscriptions. For over a century, the superpowers of Tikal and Calakmul fought a devastating series of wars that drew in nearly every major city-state in the region. In 562, Calakmul and its ally Karakol dealt Tikal a catastrophic defeat. The city's ruler was likely captured and sacrificed. Tikal entered what scholars call the hiatus, a period of roughly 130 years, during which no major monuments were erected, and the city's influence collapsed. Calakmul used the victory to install puppet rulers across the region. During this period, Calakmul built an astonishing network of vassal states. Its king, Uknum the Great, placed loyal rulers in cities like Naranjo and Dos Pilas, creating a web of alliances designed to keep Tikal surrounded and contained. At its height, Calakmul's kingdom controlled an estimated 8,000 square kilometers of territory, with a population of around 200,000 people. But Tikal wasn't finished. At the city's peak, it had housed nearly 500,000 people across its wider territory. That is a staggering number for an ancient civilization built in the middle of a tropical jungle. And that population meant resources, labor, and eventually the capacity to fight back. But the wars didn't end there. They escalated. Tikal eventually recovered and struck back. In 695, Tikal's king Jasor Chan Kawil the first defeated Calakmul in a decisive battle, sacking the city and seizing its patron god. But victory came at enormous cost. Both superpowers were depleted, and the proxy wars they'd fought had destabilized the entire region. By the 8th century, warfare across the Maya lowlands had intensified to levels never seen before. Cities that had once competed through trade and monument building were now fortifying their borders with defensive walls and ditches. The archaeological record shows a dramatic increase in weapons, fortifications, and evidence of violent destruction at sites throughout the region. And this warfare was consuming resources that the Maya could no longer afford to lose. Every soldier was a farmer who wasn't growing food. Every fortification was built with timber and plaster that could have gone elsewhere. Every conquered city meant disrupted trade routes and broken agricultural networks that had kept populations fed. There is another consequence of the deforestation that researchers have only recently begun to understand. As the forests disappeared and the soil washed into the reservoirs that the Maya depended on for drinking water, something toxic began to happen. Sediment studies from reservoirs at Tikal have revealed evidence of dangerous algal blooms in the water supply during the final decades before abandonment. Without the forest canopy filtering rainwater before it reached the reservoirs, runoff carried phosphorus and nitrogen from exposed soil and agricultural fields directly into the water supply. These nutrients fed toxic cyanobacteria blooms that would have made the water dangerous to drink. The very reservoirs that had sustained the Maya for centuries were being poisoned by the consequences of deforestation. Now picture all of these pressures hitting simultaneously. A population that had grown beyond what the land could sustainably support. Forests stripped away to feed the insatiable demand for wood and farmland. Soil eroding off hillsides that had been cleared too aggressively. Rainfall declining as the forest cover disappeared. And on top of all this, a series of severe natural droughts that pushed the entire system past its breaking point. The droughts of the 9th century weren't ordinary dry spells. The evidence from Lake Chichancánab, the Cariaco Basin, and cave formations across the Yucatan all point to some of the most severe aridity the region had experienced in 7,000 years. Researchers have identified particularly devastating drought events around 810 and 860 AD. Speleothem records from caves across the Yucatan. Those are the mineral formations that build up on stalagmites and stalactites, provide an incredibly detailed picture. The oxygen isotope ratios trapped in these formations shift in predictable ways depending on how much rain was falling when they formed. And the picture they paint of the 9th century is bleak. But here is the thing that puzzled researchers for decades. The Maya had survived droughts before. They'd weathered 5 major dry periods during the Classic period and come through each one. They'd continued building, continued growing, continued innovating. The question that haunted archaeologists was simple. Why couldn't they survive the last 2? Arizona State University professor Billy Turner II spent years studying exactly this question. His research pointed to something deceptively simple. By the time the final droughts arrived, the Maya had used up their margin for error. Earlier droughts hit a civilization that still had forest to clear, soil to farm, and room to adapt. The last droughts hit a civilization that had already pushed every system to its limit. Consider the math. At their peak around 800 AD, Maya cities in the southern lowlands were among the most densely populated places on Earth. Population estimates for the region have been revised upward dramatically in recent years, thanks to LiDAR surveys. What archaeologists once thought were small scattered communities turned out to be vast interconnected urban landscapes hidden beneath the jungle canopy. The population was eating through resources faster than the environment could regenerate them. It is the same pattern ecologists see in animal populations that overshoot the carrying capacity of their habitat. Growth continues past the point of sustainability because the effects of that growth take time to become visible. By the time the consequences are obvious, it is already too late to reverse course. Computer simulations showed that complete deforestation of Maya lands would have raised local temperatures by 3 to 5 degrees and reduced rainfall by 20 to 30%. The Maya hadn't completely deforested everything, but they'd cleared enough to push conditions past a critical threshold. And once you cross that threshold, the system doesn't recover on its own. Crops failed. And because the droughts hit disproportionately during the summer growing season, the corn harvests were devastated at exactly the worst possible time. Corn wasn't just food for the Maya, it was the foundation of their entire economy, their social structure, their religious life. When the corn failed, everything failed, and this is where the political system started to crack. Maya kings derived their authority in part from their relationship with the gods. They performed elaborate bloodletting rituals and ceremonies to ensure rain, good harvests, and cosmic order. When the rains stopped coming despite these rituals, the king's legitimacy crumbled. Archaeological evidence from sites across the southern lowlands shows a pattern that is chilling in its consistency. First, the monumental building program stopped. Then the dated stone monuments, the stelae that recorded royal histories and celestial events, ceased being carved. Then the population simply left. City after city, the pattern repeated. The collapse didn't happen overnight. It rolled across the southern lowlands like a slow wave over more than a century. It began in the Petixbatchan region around 760. The city of Aguateca was attacked and destroyed around 790. Then the decline spread to the cities along the Usumacinta River. Palenque's last recorded date is 799. Tikal's last inscription dates to 869. Calakmul's final recorded date is possibly 909. If you are drifting off right now, that is perfectly fine. Let these dates and places wash over you. The story will be here whenever you come back to it. But here is something that makes this mystery even more complicated. The collapse wasn't universal. While the cities of the southern lowlands were being abandoned, cities in the northern Yucatan, places like Chichen Itza and later Mayapan, continued to thrive. Some even grew during this period. How is that possible if drought was the primary cause? The answer goes back to that geology we talked about earlier. In the northern part of the peninsula, the water table is much closer to the surface. The Maya there could access groundwater through cenotes and wells. They weren't entirely dependent on rainfall and reservoirs the way the southern cities were. When the droughts hit, the north had a buffer that the south simply didn't have. Recent research has added even more nuance to this picture. In 2021, a team led by archaeologist Charles Golden from Brandeis University used LiDAR technology to map ancient Maya communities in the western Maya lowlands. LiDAR can see through the jungle canopy and reveal the outlines of structures buried beneath centuries of vegetation. What they found challenged the simple drought narrative. Some communities in their study area appeared to have had abundant crops and weren't struggling for agricultural resources when the civilization collapsed. The three main kingdoms they studied were each functioning in very different ways, right up until the end. Golden's conclusion was striking. The communities in the western lowlands were dealing with the challenges of drought, warfare, and political instability in very different ways. Some adapted, some couldn't. It wasn't a single catastrophe. It was a story about variability and resilience, and the breaking points of different systems under different stresses. And then there is the trade route theory. For centuries, the major commercial arteries of the Maya world ran overland straight through the heart of the southern lowlands. These routes connected the highlands of Guatemala with the coast, carrying obsidian, jade, cacao, and other goods that kept the economy of the southern cities alive. But around the time of the collapse, there is evidence that trade began shifting from these overland routes to sea-based voyages that went around the perimeter of the Yucatan Peninsula. This would have been catastrophic for the southern lowland cities. Suddenly, the geographic advantage that had made them wealthy, their position at the crossroads of major trade routes, became irrelevant. Without the revenue from trade, kings couldn't fund the building programs that maintained their authority. Without construction projects, there was no work for the artisans and laborers who depended on royal patronage. Without the flow of exotic goods, alliances with other cities weakened. The entire economic structure started to unravel. Now, you might wonder whether disease played a role. Some researchers think it did. The tropical lowlands of the Maya world were home to parasites and pathogens that thrive in disturbed environments. As the Maya cleared more forest and created more standing water through their agricultural practices, they may have inadvertently created breeding grounds for disease-carrying insects. Researchers have suggested that acute diarrheal illnesses in particular could have been devastating. If these diseases struck young children, which they commonly do, they would have impaired nutritional absorption and growth during critical developmental years. A population of chronically malnourished children would have been more susceptible to every other stress the civilization faced. And the nutritional situation was already precarious. The Maya diet was heavily dependent on corn. Corn provided the bulk of their calories, but it is not a complete food on its own. The Maya understood this, which is why they developed nixtamalization, the process of soaking corn in lime water that releases otherwise inaccessible nutrients. Without this process, populations relying primarily on corn would develop pellagra and other deficiency diseases, but nixtamalization required lime, and lime required burning trees. And burning trees was the very thing destroying the environment that grew the corn in the first place. Do you see the trap? Every link in the chain of Maya survival was connected to every other link, and pulling on any one of them pulled on all of them. And this brings us to what might be the most unsettling aspect of the entire story. The Maya weren't ignorant. They were among the most intellectually sophisticated people of their era. They had a writing system, advanced mathematics, detailed astronomical records, and centuries of accumulated knowledge about their environment. They understood seasons, cycles, and the behavior of the natural world. They even developed innovations to try to conserve their resources. At the site of Kiwik in the Puic region, archaeologists found evidence of pit kilns that were specifically designed to produce lime plaster using roughly 20% less wood than the traditional open fire method. These kilns appeared right at the beginning of the population, boom, suggesting that at least some Maya communities foresaw the problem. But the innovations weren't enough. They couldn't offset the sheer scale of the demand, and they couldn't overcome the fundamental problem that the Maya's success, their growing population, their expanding cities, their increasingly elaborate building programs, was systematically destroying the environmental foundation that made all of it possible. Think about that for a second. The very things that made the Maya great, their ambition, their creativity, their ability to build on a monumental scale, were the same things that doomed them. Their greatest achievements were inseparable from their greatest mistake. At the site of Copan in modern Honduras, researchers studying pollen cores from nearby lake sediments found something surprising. During the late Classic period, right before the collapse, the ratio of tree pollen to herb pollen actually showed signs of stabilizing pine pollen, was even increasing in some areas. It is possible that the Maya at Copan were attempting more controlled ecological management, but it may have been too little, too late. The soil damage from centuries of aggressive farming was already done. The archaeological record at Copan shows thinner layers of stucco being used on buildings during the late Classic period. They were literally running out of resources to maintain what they'd already built, let alone build anything new. And this raises a question that historians and archaeologists have debated for decades. Was the Maya collapse inevitable? Or could they have made different choices? Some scholars argue that the Maya were trapped by their own political system. In a world of competing city-states, no single king could choose conservation over construction without losing power to a rival who wouldn't. It was a collective action problem on a civilizational scale. Everyone could see the forest disappearing. No one could afford to be the first to stop cutting. Others point out that the Maya weren't a monolithic civilization. Different cities responded to the crisis in very different ways. Some intensified their building programs in a kind of desperate doubling down. Others seem to have attempted conservation measures. Some communities appear to have relocated to areas with better access to water. The responses were as varied as the city-states themselves. At the city of Caracol in modern Belize, archaeologists found evidence of agricultural terraces built into the surrounding hillsides, a sophisticated technique for preventing soil erosion and extending the productive life of farmland. Caracol's settlement area was enormous, larger even than Tikal's, and the terracing suggests that at least some communities were actively trying to manage their environmental impact. But even these innovations couldn't hold back the tide. Caracol's terraces and raised field systems were eventually abandoned too. The agricultural infrastructure that had sustained one of the most populous Maya centers simply stopped being maintained. And without maintenance, without the labor force to keep the terraces clear and the channels flowing, the systems collapsed almost as quickly as the political structures above them. The collapse spread from city to city like dominoes, falling in slow motion. The Petexpatun region went first, destabilized by the brutal wars between Dos Pilas and its neighbors in the late 8th century. The twin cities of Dos Pilas and Aguateca had stood on a high plateau above Lake Petexpatun, fortified against attack. Despite their defenses, Aguateca was overrun around 790. From there, the abandonment cascaded westward along the Usumacinta River, then spread east and north, Each city's fall disrupted the trade networks and political alliances that neighboring cities depended on. The system that had sustained the Maya for centuries was eating itself from the inside. By the time of the collapse, as archaeologist Thomas Sever put it, every square mile of soil had been turned over. The landscape that had once supported one of the most dense and sophisticated civilizations in the ancient world had been fundamentally altered. And the Maya had done it themselves. But the story doesn't end there, because the Maya didn't disappear. Their descendants still live across Central America today. More than 7 million people speak Mayan languages in Mexico, Guatemala, Belize, Honduras, and El Salvador. The culture that produced those incredible cities survived the collapse of those cities. In the northern Yucatan, Maya cities continued to function for centuries after the southern collapse. Chichen Itza became a major power. Later, Mayapan dominated the region. Cities in the Guatemala highlands thrived. The last independent Maya city, Nochpoten on an island in Lake Petanitza, didn't fall to the Spanish until 1697, almost 800 years after the classic collapse. The Spanish conquistadors who arrived in the early 1500s found Maya communities that were still vibrant, still organized, still maintaining their traditions and knowledge. The Maya they encountered weren't the broken remnants of a collapsed civilization. They were the descendants of people who had adapted, who had found new ways to live when the old ways stopped working. What collapsed wasn't the Maya people or Maya culture. What collapsed was a specific political and economic system that had pushed its environment beyond the breaking point. The cities of the southern lowlands were abandoned not because the Maya forgot how to build or farm or govern, but because the land could no longer support the way they'd chosen to build and farm and govern. And here is the part that keeps researchers up at night. No pun intended. The parallels to our own situation are hard to ignore. A civilization that understood its environment but couldn't stop exploiting it. A society where short-term political competition prevented long-term environmental planning. A world where success itself created the conditions for failure. Today, Guatemala is undergoing rapid deforestation that mirrors what happened over 1,000 years ago. Climate models predict that droughts like the ones that devastated the ancient Maya will become more common with climate change. The Yucatan Peninsula is once again being stressed by the same combination of forest loss and water scarcity that brought down one of history's greatest civilizations. Robert Oglesby, the climate modeler from the University of Nebraska, who studied the Maya deforestation feedback, put it simply, our reshaping of the environment can often have unintended consequences, and we may not have any idea what they are until it is too late. The Maya understood their stars, their seasons, and their soil better than almost anyone in the ancient world. They built water systems that sustained millions of people in one of the most challenging environments on Earth. They created a mathematical and astronomical tradition that rivaled anything being done anywhere else at the time. And still, they couldn't see that the very thing making them powerful was the thing destroying them. Or perhaps they could see it, perhaps some of them understood. But understanding a problem and being able to stop it are two very different things, especially when the problem is woven into the fabric of everything your civilization is and does. That might be the most important lesson the Maya have for us. Not that civilizations fall, they all do eventually, but that the fall can come not from weakness, but from strength, not from ignorance, but from the inability to act on what you know, not from a single catastrophe, but from a slow accumulation of choices that each seemed reasonable at the time. Somewhere beneath that canopy, the temples still stand. The plazas are still there, buried under 1,000 years of soil and roots. The reservoirs that once sustained hundreds of thousands of people still hold their shape, even if they haven't held water in centuries. The Maya built things that lasted. They just couldn't build a system that lasted with them. And tonight, as you lie here listening to this, 7 million people who carry Maya blood and speak Maya languages are going about their lives across Central America. They farm, they trade, they tell stories. They remember the civilization that built those incredible cities didn't vanish. It transformed, it adapted, it survived in a different form, which might be the most hopeful part of this story. The Maya collapse wasn't an ending, it was a transformation. The people survived even when their cities didn't. They found new ways to live when the old ways stopped working. They let go of the structures that were destroying them and held onto the things that made them who they were. The jungle has reclaimed what the Maya built. But the Maya haven't been reclaimed by anything. They're still here, still speaking their languages, still farming their ancestral lands, still looking up at the same stars their ancestors mapped with such extraordinary precision. Maybe that is the real lesson. Not how a civilization falls, but how a people endure. Not what was lost, but what survived. The cities crumbled, the political systems collapsed. But the knowledge, the culture, the connection to the land, those things found a way through, and the mystery remains. We know more now than we did a decade ago, thanks to climate records and LIDAR and soil studies, and the patient work of archaeologists in the tropical heat. But we still don't have a complete picture. We probably never will. The Maya collapse is one of those puzzles that keeps revealing new pieces the more carefully you look. Every year, new studies refine the picture. New LIDAR surveys reveal cities we didn't know existed. New sediment cores push the timeline forward or backward by decades. New interpretations of hieroglyphic texts reveal political events we hadn't understood. The Maya are still teaching us things, 1,000 years after their great cities went silent. If you've made it this far, thank you for spending this time exploring one of history's most fascinating and unsettling mysteries. And if you drifted off somewhere along the way, that is exactly what this was made for. Either way, subscribe and stick around. There are always more mysteries waiting. The jungle is quiet now. The temples sleep beneath the trees, and somewhere beneath the soil, the white lime plaster of a civilization that reached too far still catches the light when the earth shifts and the roots pull back. The Maya built their world in white, and the forest, patient and enduring, painted it green again.